Mic should work. Can you guys see it on the stream? Seems like it's going through, so.
You got tonight quite the crowd, Jason. All right, let's hear you rip it, bro. Woo!
All right, so let's go. I'm gonna be talking today about IPTables based off of Simon's talk last week. I figured it'd be a nice talk to do like practical application of firewalls. There we go. So we're gonna get into it. Assuming. All right, so what is IPTables? It is one of the built-in firewall packet filtering tools that you can use on Linux distributions. Other ones that exist are Firewall D and UFW. If you guys did the challenges last week, you will see that both of those were used. This is great for making your firewalls and protecting your services and making it harder for people to get access into your box. It's also great for showing you what your firewalls look like and what packets and how many packets have been caught by your rules and how well you're doing protecting your network on your host device. So fundamentally, IPTables starts off at a table layer. There are different tables for the different components of the network layers, kind of, sort of. So the default table that is used is the filter table. It's where the majority of the rules are placed, and it's what most people use to protect the network. It's the default table. There's the NAT table, which you can use to alter the source and destination IP addresses in case you wanted to use your box as a kind of like a server and like NAT your network and NAT your traffic. That is pretty good for proxies. There's also the Mangle table, which allows you to change and interact with the IP header within the packet, and you can change the destination and the destination and source there as well. There's the raw table. So a little bit about firewalls. You're gonna have stateless or stateful firewalls. IPTables is stateful, which means that it looks in through the packet and to really like the meat and the bones of what's going on, and it'll track how many gateways, I believe, the packet has been through already. So if you can use the raw table to turn off the tracking feature so that it becomes a little bit less stateful. So it stops connection tracking. And finally, if you're using SE Linux, then you can use the security table to integrate IPTables with that and specify specific things you want SE Linux to do with the packet as it comes in. Within each table, there are chains. There are 3 default chains: input, output, and forward, that let you specify like the types of organization you want to have with your rules. So a chain at a fundamental level says the list of rules that are going to happen to traffic and packets that come in on that network or through that table. So beyond the default ones that you have, you can also have your, like, custom user-defined chains within the tables. Any questions so far? Beautiful. So now I'm going to start to talk about like actually using IPTables and starting to build a firewall. But first, a quick review. So the best overall ways to build your firewall: start with a default policy to accept all your traffic. In the event that Red Team flushes your firewall rules, you don't lose access to your cloud boxes or to scored services because you said deny all. After you've done that, you want to drop all the traffic so then you can create individual rules for the scored services that you need, so that you're not having every single thing come in with the stuff you don't need. So your box is only scored on SSH, but won't be letting HTTPS traffic come in, because you just don't need that. Once you're done writing your script, add a sleep 5 and then flush to make sure that everything you wrote actually works. And if it doesn't, and like say you're SSH'd into a cloud box, you apply firewall rules, something breaks and it blocks SSH, your shell hangs, but now if you didn't flush, you got nowhere to get back in because your firewall rules are blocking it. So good job, you wrote good firewall rules, but not good for you because you can't get back in. Once you verify that your stuff works, comment out those 2 lines, spin them up again, and then you got good firewall rules, you can still access your box, your services are still scored, and you're not allowing extra traffic in. But also, make sure that you go slow. You don't have any time and competition or any typos. So make sure that you're typing things correctly the first time around. Save yourself from fixing it in the future. So going over the syntax of the IPTables command, the first thing is IPTables. The second thing, you can specify the table. As I mentioned earlier, there's the filter table, there's the NAT table, there's security tables. If you, this would default if you don't include anything to the filter table, and that's what most firewall rules do. But if you wanted to write NAT rules, you could by including a TAC T in the NAT, and that would be how you write rules to the NAT table. Beyond that, the majority of the commands work with a TAC capital something. So the big ones are TAC A and D for add and delete, or TAC F for flush, TAC L for list. So, and there's also TAC I and R for insert and replace at a specific rule number in the chain. The way that chains are numbered, the first rule you put in is number 1, and it indexes up from there. So if you wanted to, like say you have 5 firewall rules, it was that your 5th one is broken, you could do, and like you realize this not outside of your script, instead of changing it and going back to your script and then spinning that up again, you could run IPTables from the command line. Like you could do IPTables, TAC R, probably filter, well, probably input for your chain, and then number 5 for your number to replace, and then whatever you want to change to make it better. So the other key thing to talk about is options, and this is how you create good and specific firewall rules. So it's TAC P for protocol. This allows you to specify TCP, UDP, or ICMP, or you could do a TAC all for all of them. You can specify your source IP address or your destination with TAC S or TAC D, and then finally at the end, like once you have a packet that matches that criteria, you use TAC J to tell it what to do. In most cases, you're going to use drop or accept, but you could also have another rule base, another chain that you wanted to go look at. Say you wanted to log all your all of your dropped packets. You would, at the end of your rule specification, you do a TAC J logging, goes to that chain, filters through those rules, and then after the end of those, it'll do a TAC drop if you wanted to drop all the rules, if you wanted to log all of the packets that you dropped. Then one of the key features that makes the IPTables really powerful is using the TAC M option, which allows you to match specific criteria. For example, like a port number, you would like S port or D port. You could also use ICMP type to go for ICMP requests or replies. And there's lots of other options that we're not going to get into, but you can check them out in the man pages. So now, after we understand how to build a firewall rule from a conceptual level, as well as the specific context and syntax for IPTables, we're going to do a little walkthrough of how to write a good firewall rule for a specific box. So this is our topology, and we are using the Canute box, and we can identify our scored services and then write some firewall rules to let those services be scored but protect everything else. So the Canute box has scored services of ICMP and SSH. For the most part, unless the SSH config has been changed, it's going to run on port 22. ICMP is a protocol, doesn't have any ports, so we don't need to worry about that when we go to write our rules. So as I mentioned earlier with the chains, you have a chain for input and output. So to get a good firewall rule up, you need to have 4 rules for both SSH and ICMP. Since we want SSH to be scored, we need to allow incoming connections. They need to be allowed to connect. Well, the connection needs to be two-way. So, the connection needs to be able to send and receive data from the box. So, you need to allow traffic in. You need to allow the traffic out. So this is a basic rule. We should do accept for both. And the second rule here also allows us to SSH out into other boxes across our network, which is good if you want to jump to the cloud boxes that we have. For the ICMP, like the incoming allows to ping requests, and the outgoing allows to ping replies. However, we can make our SSH rules a lot better by using the TAC-M, the match option. So say we wanted to make our rules better, and we didn't want to have pivoting allowed on our network. Since our SSH connection only needs to send and receive data, we don't need to have outgoing connections happening. We don't need to have new outgoing connections happening. So we change our rule, we add a TAC-M, and we can use the state, and the state needs to match like new or established connection for our incoming connections. And then once our connection comes in, it has already been established. So we can have it in our outgoing rule, we have the state established so that the connection that comes in, it's verified, it's good, then it can go out, but we're not making a new SSH connection, so we're not allowing pivoting across our network by allowing new things to come out of our box. The side effect of this is we are not allowed to SSH out of our box anymore. So we can't jump to the cloud boxes or use SSH to access other things. But this is a better set of rules for scoring because our score services can come and get the check. It can be verified, it can go out. And red team can't use our box to jump around the LAN or the cloud any longer. So the rest of the traffic that we talked about, we've written our rules for our scored services, but we need to drop everything, and we need to have default policies to accept things in case the rules get flushed. So we used IPTables TAC-P, which specifies default policy to allow to accept everything from the input and the output. And then we write a rule by appending or adding a rule to just drop everything from the input and the output once we have our default policy. So putting it all together, this is what our script should look like, where we have our default policy up at the top, then we drop everything, we write our two ping rules, then we write our fancy SSH rules, then we have our sleep 5 and our flush, so we can test things and to make sure it doesn't actually work. Thank you. I spent a little bit of time on these memes. So always remember, so after you're done writing your script, make sure that you're not just writing things directly to IPTables from the command line. Make sure that you put these in a script so that when red team flushes your rules, you can just / your script, spin them back up again, and then you're ready to go again. And of course, once more time, sleep 5 and flush so that you don't brick yourself accidentally.
More importantly than blocking your services if it's a cloud box, also don't want that to not be accessible.
Yes. So here are some other good practices that you can do to write a bit more fancy firewall rule stuff. Can I move this? Move that over there. So if you want to write some better ICMP rules, then you can specify using the TAC-M. No, not the TAC-M, I guess. Using this ICMP type, so your echo requests come in, your echo replies can go out, and then you can send out your echo requests and you can receive your echo replies. Then if say you're on a server box, you want to have connections to yourself, you can allow loopback addresses to connect to yourself. and then DNS rules. And lastly, some more resources. Always read the man pages for good, like verified truth. That's the universal truth on what the tool does. And here's some other websites to translate the man page into something that you can actually read. So, any questions? Does everybody feel confident that they can write a good IPTables firewall rule script now?
Yeah. Can I use these for UV? Should I use this advice?
Yeah, yes, you should. Yeah. And unfortunately, we lost our one person who's going to Wait, you're going to UB tomorrow?
Yeah.
Ah,
I'm not going.
oh, whoa.
Yeah, I'm doing UV.
Dope.
Hey, listen,
All right.
don't break those rules, you'll make red team upset, and then they'll just use raw sockets on you.
He'll do that anyways.
Yeah, that's true.
Yeah, where's the sign off for the stream?
Sign off.
Stream off, Jason, that's all you get.
Well, it has been a pleasure to talk to you all today. I do appreciate all X of you. All 13 of you coming out today. I really appreciate it. I know that half of you are in the audience here in person, but you know, I love you guys anyways. Catch us next week, 12:20 to 4 o'clock, maybe, unless we end up being short like this. Ooh, this is true. We have an alum coming back to teach us some stuff, and it's going to be amazing. And just have a fantastic weekend. I know the weather kind of sucks in Rochester, but make the best of it. And that is all for today.